In the last presentation, we took a closer look at the size of operator. In this presentation, we'll look more closely at scanf and understand why the arguments it receives are the addresses instead of the values of variables. We'll begin by further analyzing two examples we saw in class using scanf. As we begin to understand the arguments to scanf, we'll also be introducing ourselves to pointers. So to review, in class we saw this example asking for three integers separated by commas. Scanf takes a format string which has three type specifiers, all for integers, that's the %d, with commas in between the d's. And the arguments to scanf are the address of x. Remember that the ampersand tells it to get the address instead of the value of the variable, address of y, and address of z. The return value for scanf is the number of arguments that were read. Recall that as soon as scanf encounters an unexpected character, it will stop reading. So when scanf is successful, num read will equal 3. If scanf fails, num read could be 0, 1, or 2, depending on where the bad character was encountered. So let's see what happens when we try some sample input. First, I'll enter the correct case of numbers separated by commas, 1, 2, 3. In this case, 3 values were read. Another case is when I forget to enter the commas and instead I enter a space, 1 space 2 space 3. In this case, only the first integer is correctly read. After that, scanf encounters a space, which it is not expecting. Since we told scanf to read in a comma, it can't proceed any farther after the first integer is read. The numbers that we see here are garbage values, values that are stored in the uninitialized variables y and z. One more point I'd like to make is that instead of having commas, you could also use other characters, such as letters or other punctuation marks like periods or underscore. The behavior of scanf would be the same, that it would expect to read the character that you specify, and if it doesn't find it, it would give up. Now let's take a closer look at another example we saw in class. We saw this example using scanf to read an integer followed by a character. When we attempted to do this without clearing the buffer, scanf would successfully read the integer, but the character would automatically read the new line which was left on the buffer after the integer. The solution to this problem was to get the new line off of the buffer. A single call to getChar is sufficient to clear the buffer in this example. However, it is safer to use a while loop. Which can still clear the buffer if there's extra characters between the value that was entered and the new line. What I wanted to add is that this problem only exists because we were reading a character. Had we been reading an integer, we would have never noticed the problem. Here, I'll replace the character C with another integer that I called J. And if I remove the while loop that we were using to clear the new line character, this example will still work. As you can see, it correctly read the second integer that I entered, the number 4. The reason why this works for integers, or anything but characters actually, is that when you're entering non-characters, white space gets ignored. White space being spaces, tabs, or new lines. Characters, on the other hand, will read in white space. So as we saw with that example, white space is ignored except when reading characters. Now we're in a position to answer the question, why does scanf take arguments that are addresses instead of values? Recall that all variables have a value associated with them, as well as an address in memory for where that value is stored. In the picture, the variable x has a value of 10 shown inside the rectangle, and the address is shown to the right on the outside. It's given in hexadecimal form. The point here is that scanf reads in a value, but it needs to know where to put it. And to answer the question where to put it, you need an address. So the arguments of scanf are addresses so that it knows where to store the values. Now, how do pointers fit in? Well, a pointer is simply a variable that stores an address, and you declare it with an asterisk after the type. So in this example, we have pointer to x is an integer pointer because it points to the address of x, which is an integer. If you look closely at the figure, you'll see that the value inside of the rectangle next to pointer to x is the address of x. The reason why they call them pointers is because they can be thought of as pointing to other variables, as can be seen here. Now let's look at a short example to illustrate these concepts. In this example, we have the same code that was described in the previous slide. We have an integer x that's equal to 10, and another variable which is a pointer to integer called pointer to x, and it's initialized with the address of x. The user is asked to enter an integer, and scanf places the value the user enters at the address of x. However, pointer to x stores the address of x. So instead of putting address of x here, we could put pointer to x. And let's see if the value of x changes when we print the output. And there we can see that the value of x has changed. In this presentation, we found out more about how scanf behaves. We also understood why scanf takes as arguments addresses instead of values. Lastly, I introduced the idea of pointers. It's important to remember that pointers are simply storing an address. Now please attempt the following multiple choice question on these topics.